So the challenge is using the Fitch derivations to for input, for data input, and for checking the Fitch derivations for correctness. And this is the main challenge. Is associating some mathematical theorem with a Fitch derivation and then entering it into the computer. One of the challenges is translating between the ASCII file representation and the mathematical notation. So the question is where, how does, if this is a computer program, then how does it interact with the user? What does the user interaction look like? And in particular, when does the user see Fitch derivations in typeset mathematics? So, first of all, I think the issue with one of the issues with mathematics is being able to fit enough content onto a single line to be satisfying. And the thinking here is that in ordinary mathematics, notation is the gold standard for line length. And line length content, not just line length in inches, but line length, it's the density of mathematical content. And the thinking here is that mathematics notation gives the gold standard by which all other densities, it is the most dense method of, I'm not sure if this is 100% true, but if it isn't the most dense, then it's certainly substantially more dense than the ASCII typesetting input, the input that you give to the typesetting processor. So, the issue here is the density of content per line. So it's content density per line. There's no way of measuring this that I know of. At least, maybe there is, I just can't think of anything at the moment. But the thinking here is that if we want to be simple about it and oversimplify, and we just say that ordinary mathematics notation has, let's just arbitrarily say it has a density of 1. And and you just say that, and then you look at the ratio of lines of typesetting or whatever to lines of ordinary mathematics notation. You look at that ratio, and that's your density ratio. So the thinking here is that part of what we're doing is we're creating an interface that respects the ideal density of mathematical content per line. So the issue is per line density, and I think we know how to measure it, but the question is, how is it going to be displayed to the user? Are we just going to put this in a PDF, and are we going to make the user wait for the rendering of a PDF document? Seems unlikely. Using MathJax in a single-page application, this seems a lot more likely. The thinking here is to use multiple canvas elements and to arrange the canvas elements in ways that correspond to the indentation level of a particular line in a Fitch derivation. And then to use the formatting, the HTML formatting, using a table or whatever, to display the result. And that this is going to be the interface that the user will have. Another option is OpenGL. So there are various interfaces. One of them is called LDFS, Lovely Day for Salsa. It's a meaningless name, but it's an OpenGL interface for Windows that uses C. So this is yet another option. This is using this option demands, in my view, two other options, two other choices that must be made. One is to find an interface to tech that renders the output in a way such that the OpenGL system can access the bits and then display them. I don't know how this is supposed to work. It's just a blank spot for me personally. What you run up against then is a choice between the performance of C versus the performance of JavaScript. Obviously, C is going to be higher performance. For a workload, you're going to get better performance with the executable standalone. There's no question about this. And I think sort of the third option, which is, the join or the meet or merge or whatever, is to pursue a combined strategy of a JavaScript single-page application and a Windows standalone executable, or even a Macintosh standalone executable that performs the activities of displaying typeset mathematics to the user. Okay. And I think there's this last option, which is sort of downloading a copy of Lix, trying to build it, and if I can build it, this is the challenge, then hacking it up and trying to add a Fitch derivation facility, which is an interesting option, but it doesn't, you're going to require, I'm not even sure what. I'm not even sure this makes a whole lot of sense. It certainly sounds, I don't know, perhaps we can use the imagination for a little bit and imagine a menu option in Lix that allows you to check a Fitch derivation as long as the types of inference rules are mentioned along with how the inference rule is applied. I think that's possible. I would say, given that it's an open source, I think creating a standalone open source application in C or C++ would be a good stepping stone to adding that feature. And then, of course, abstracting the computation of that correctness, sort of like spell check. It's inference check. Abstracting that, or rather moving those functions into a library, and then looking at how Lix accesses extension modules, or simply checking it into a static library in Lix. This is a really interesting sort of point of view, which sees what I'm going to call the math auto grader. It's an inference rule check, just like spell check. So it's math spell check. The point is that now seeing this project or this program in the context of its development into a feature of an open source program, it happens to be this Lix OIX document processor. So it's sort of a nice kind of outlet for this activity. As clearly, maybe not clearly. Who knows how popular or useful it'll be in the short term, the next 10 years. But, it's a trajectory.